go ahead and start. I'm Christine Gambino. I'm currently the project manager at Data Science Alliance. So I do want to give a disclaimer since this is that's also the host of our event. Right now, I'm not wearing my project manager hat. I'm wearing my subject matter expert about town hat. And the views and opinions expressed in this presentation are mine, and they don't necessarily reflect the official policy or position of DSA. However, I do think the talk today I'm going to touch on a lot of the pillars of responsible data science that we do try to promote at DSA. These are the 4 pillars that we talk about in our framework for responsible data science as a community. And specifically today, we're going to talk about the link between equity in sampling and inclusion in a study, and the effect of that on veracity, really, the inferences that you can make and the conclusions you can make from a sample to a population. And then I'll also talk about the trade-offs that exist between the goals of transparency and privacy. A lot of times they are at odds with each other. And I've learned over the years a few tricks of the trade for making compromises, and I might share a couple of those with you. So does anybody know the difference between statistics and parameters? Any of our student volunteers or any of our seasoned practitioners? Kayla, do you know? This is a reverse interview. All right, parameters. It's important because parameters are numbers that summarize data for an entire population, and statistics are numbers that summarize data from a sample. Okay, a sample, of course, is some subset of the entire population. And a survey can actually describe either. A survey can technically be performed on an entire population if the population is really well defined and small. So for example, I could have a survey of my soccer team and what color jersey do we want to wear? And then 75% said yellow, 25% said blue. Those are parameters, really. Those are descriptive or descriptive statistics that I'm giving you right there. They're not inferential statistics because the whole population was sampled using a survey. And doing that can eliminate any potential bias through sampling techniques, but other than that, it's usually not really justified for the time consumption and the resource consumption that you would use in a lot of different real life study. Well, I mean, your soccer team is real life, but thinking about studies of the population or the community or the environment, there's surveys of land, right? If you're here to learn about land surveying, I think you're probably in the wrong class, wrong lecture, but land surveying even is a survey as well. So if you think about a land surveyor that is taking a measurement at this point, measurement at the next point, and they are looking at the difference between those 2 measurements. Well, this one is this much higher, this angle higher, this one is to the right a little bit. They're not measuring all of the details in between. They're not literally taking like plaster, mold and molding the entire ground. Or they're not, now we do use LiDAR, or, we use a lot of different aerial surveying devices to make more measurements. But even so, land survey usually is like a fuzzy, kind of low resolution picture. Literally often it's a low resolution picture of what you would see if you were right there on the ground looking at that particular road. So what a survey really is where you jump in and you measure parts of something, and then you make an inference about the whole thing, right? So a census is supposed to be a complete enumeration of the population. That's the definition of a census, right? We just had a census, a decennial census in 2020. And do you guys think it counted every single person? The mission was to count every resident of the United States. Probably not, right? Probably there are some statistical methods being used, or there were some statistical methods used to correct for the little bit of undercount that happened. But still, the census is considered to be the true count of everyone. As far as I know, it's still the best count. But they only ask a few questions on that. Mostly it's just to determine how many people are in the population. And the more interesting questions often require more respondent burden. Maybe a long interview that takes half hour, an hour, or maybe you get something on your phone that you absolutely don't want to answer, but you do it anyway. It's some sort of respondent burden required when you ask people to complete questions or be measured by a survey. So the lessons that I want to give today are learned from a couple of the surveys that I've worked on that ask some of the more interesting questions, I think. The American Community Survey is, I think, it is the largest survey in the United States. It samples 3.5 million households, and it's used to determine $675 billion in federal funding. So the number of schools, the number of roads, a lot of other things are determined based on answers to the American Community Survey. I worked on that for about 9 years, and before leaving to come to San Diego, I was the head of content for American Community Survey. So I was in charge of cognitive testing for the questions that went on there. I also worked on the current population survey while I was there at the Census Bureau. That one is a little bit smaller sample, but it delves even a little bit deeper, and you probably know that one best from the unemployment rates that you get. The Bureau of Labor Statistics sponsors that survey, and the March supplement determines our official unemployment rates in the US. So after working at Census Bureau, I had the privilege of being appointed to the position of the first Chief Data Officer of the County of San Diego. So in 2018, I moved out here, and I've been here and staying here. And a lot of the survey methodology that I needed as Chief Data Officer was in community health studies. Public health is a really big deal in county, so we'll get into that a little bit later. And then I also had the privilege of taking a few semester-long classes from a graduate program called the Joint Program in Survey Methodology, which is run jointly out of University of Michigan and University of Maryland. I think it's one of the best programs in the country. And so I'm just grateful to all of my mentors and professors from those areas in my life who taught me these things I'm going to share. All right. So I'm going to get into an example because talking about people is sometimes a little bit boring, and penguins are cuter, I think. So the example I'm going to use for how you might run a survey is counting penguins in Antarctica. Most of the penguins in Antarctica are characterized as emperor penguins. And counting them is a hot topic because the species is on the border of near threatened and vulnerable. And where they fall on that level of threatened depends on their population. And the reason they're on the border is because of some measurement errors or improvement in measurement, their population kind of goes up and down in between those different categories. But they're projected to undergo a population decline over the next several decades because of climate change. Ice shelves melt sometimes, and you notice that the population decreases a lot. So let's say biologists are worried about a communicable disease called penguin flu. And this also actually exists. There are bird flus that can be transmitted from species to species, and sometimes they jump and become a flu that affects penguins. Previous studies of penguins have found that multiple species of the bird carry antibodies in their blood that will protect them from this flu. So let's say you're a penguin scientist and you want to know what percentage of this bird population, this penguin population, carry flu antibodies in their blood. Right? This sounds a little bit like some studies that public health would have been doing the last couple of years, right? So scientists want to know, how can they predict the outcome on the penguin population by learning what percentage have those flu antibodies? How would you find this out? Anyone have an idea? Would you go and actually capture on this beach here all 600,000 of these penguins? Could you? You really probably could. You ideally. So can anyone kind of explain to me what the idea of random sampling is? No, I'm sorry, there's something in chat. Someone's in chat. Oh, Kayla. That's why we're here. That's why we're here. So a lot of this, the statistics part is stuff that I learned in school, but also a lot of it was stuff that I learned out on the job. So really, I'm just really touching on the statistical concepts that are kind of the most important. Random sampling is probably the real crux of survey statistics, because why? One reason is probability sampling, which I'll talk a little bit more about later. When you have an equal probability that each one of these members of the population may fall into your sample, that can be achieved by randomly selecting them. And the advantage of that is that you can make better inferences. You avoid bias. But another reason is because you need to develop a standard error a lot of the time. So if you have a random sample, a lot of the statistics you may do have the assumption that you did some generally accepted random probability sampling. And so we'll get into that a little bit later when we talk about analysis and why you'll be glad that at this point, when you're looking at your penguins, you randomly sampled them. What if you just like ran down the beach and you just collected, let's say you need to collect 30 of them, and you just ran for them and you just collected the first 30 that you got. Is that fine? Well, what if, so a lot of the penguins are going to just run right in the water, right? They're just going to leave because you're going to try to take their blood and you're going to try to capture them, and it's invasive for them. So a lot of them will run into the water. Let's say there's faster penguins and slower penguins. So what if there's some sort of correlation between being a fast penguin and a slow penguin and having that flu antibody? Maybe kind of the slow penguins are less like, let's say it's been found, the slow penguins are less likely to have the antibody because they don't get around as much. They're like homebodies, they just don't travel as much or something. The fast penguins are more likely to have the antibodies. So in that sense, if you grab the first 30 penguins you see, they're going to be slow penguins probably, and they're going to be less likely to have that antibody, and then your percentages are going to be skewed, right? Right. So really quickly, the general stages of a survey life cycle are these. I'm not going to talk as much about 4 and 5 because that's covered in a lot of our other seminars, a lot of our data skills. And if you're a data scientist, probably that's the crux of a lot of your studies already. But I think that 1, 2, and 3 are things that a lot of times you learn on the job, and that I've learned on the job. But you can apply these lessons from these really large surveys to a survey of your soccer team, or a survey of the environment, or an organizational survey you run on SurveyMonkey or something like that. But I'm just definitely going to talk a lot about collection and getting that representative sample. Any questions right now? Yeah. So, all right. Sorry. The first step before you collect anything is you have to justify why you're doing it. This is the first step, should be the first step of any analytic endeavor, survey or otherwise. You need a justification, and then you need to write it up. A lot of times your funders will require this, but it's also the ethical reason. It's also the best practice. It's a responsible data practice to figure out why you're doing something and not just go out and collect data. You want to know the potential users or decisions the survey question is designed to inform. That will tell you what the precision required of the estimates will be, what statistical power you need, how many people you need to sample. You need to know about related and previous surveys. What else is out there? What steps could you take to prevent unnecessary duplication with other sources of information? Again, just so you're not bothering people for no reason. When and how frequently users are going to need the data. So how often do you need to repeat this survey? And then something I actually didn't talk about, I skipped over a point back here, which is a surveillance point. And I have to say, it's in my early career and in graduate school, I did a whole lot of research that was time limited. It was, here's a project, now you're done, report your results, and you're done. But in my professional life, a lot of my what I've been paid to do would fall in the category of surveillance. And that sounds scary, right? It sounds like I'm standing outside your house with binoculars. I'm not. But the definition of surveillance is a survey that never really ends. It's just an ongoing survey of something. So the American Community Survey is one, current population survey is one. Today, right now, as we speak, someone is out there interviewing somebody for both of these surveys. because they do it every day, all the time, unless there's some pandemic or something that shuts it down. It's pretty much rain or shine. The surveillance activity, I think that is the most impressive to me in the last couple of years, was working with the epidemiologists in the county of San Diego, right? So how do you think that they produce all those statistics that say this many coronavirus tests have been run and this many were positive and this many vaccines have gone out and this many people were hospitalized, this many people died? It's because it's not a method that was set up because coronavirus happened. It was a method called surveillance. There's a budget for it. It's an activity that epidemiologists are tasked with. Dr. Wilma Wooten runs the whole show in our county. And the legal requirement is that hospitals have to report, when someone comes in with a communicable disease, they have to report it to Dr. Wooten in her office. So there is a reporting system, and that is called surveillance. And it's just, the hospitals, the clinics, eventually like the CVSs that were running tests, every place is legally required to report their findings in a certain way that the county requests to the county. And in that way, they were able to come up with daily statistics. We did have to ramp up a plan that was, a process that was done monthly to a process that was done daily, and then also give all of our findings on the news in a press release every day. So that was pretty intense. But as far as collecting the data and having it be accurate, that surveillance system was already set up, and it is in pretty much every county by the public health people. So back to survey design, I'm just kind of gonna go through this pretty quickly. But one thing you're going to need is a sampling frame. What is that? Is it the population? It's kind of like the population. So a sampling frame is all of the possible people you could sample, or all the possible units you could sample. Penguins, spaces on the land, whatever. And a sampling frame is just really the part of the population that you have access to. So you can just kind of think of it as the population. But you need to specify the sampling plan. What questions are you going to ask? And how are you going to ask it? When you're talking to people, it's really popular these days to use the internet. It used to be really popular to send everyone just a letter in the mail that said, please answer our survey. Here's a self-addressed stamped envelope. People don't know what that even is anymore. But there's a lot of research now that you can looking at data collection instruments and methods and how they work, better or worse for different concepts. So here's a question for you all. How many ways do you think there are to accurately measure something? Let's say it's penguin antibodies. You think it's one? Shake your head and yes or no. Do you think it's two? Between 2 and infinity? Or infinite ways? Kayla says D. Maybe. That's a cognitive scientist perspective, Kayla. We can do this infinitely. All right. So I mean, I don't know if it's infinite, but I know it's definitely at least C. I've never ever been in a situation where we sat around going, okay, how many different ways could we ask this question? And then said, okay, well, there's 10. And that's it. Okay, done for the day. It's more likely, you sit there for 3 hours and you're like, okay, now we got to go home for dinner. And then you cut it off and say, okay, let's choose something. But you got to get creative. And I think there's a lot of lessons you can learn in different classes. I studied developmental psychology in school, so I got learned a lot of really neat methods about measuring people who are nonverbal, meaning maybe little kids. And how to tell, whether they can tell us something is the same or different, or how they cognitively characterize something. But some of those methods also apply toward if you are interviewing someone who doesn't speak your language and you have no hope of learning their language. And you need to do something like, let's say what I'm trying to measure is, what is the color of that big rectangle on the page? That's what I want to ask you. What is that color? I could ask it like that. I could say, what is this color? I could say this color is what? I could say, what is this color? In parentheses, green, purple, red, violet. I could give you a list of examples. I could give you a checkbox where you check and you have your forced choice. So if you think it's like kind of green and kind of something else, you have to choose green. But I could give you a write-in answer where you could write a whole poem on the color that you see. But a good way to do it non-verbally might be, I could give you 3 colors, the green, red, and blue that I have here, and I could say, put 2 that are the most similar together and 1 that is the most different to the side. And I could do that with a whole bunch of different colors. And even if you didn't understand my language, I could show you a whole bunch of things that are like 2 are similar, 1 is different, 2 are similar, 1 is different, 2 are similar, 1 is different, and then I start with the colors. So, there are just so many ways to measure something. In your surveys, you're going to select one, but you should know that there are just a million different ways you could do it. And what's best is if you have a concept that is measured different ways in different surveys, and you can compare those results. That's when you really learn about a thing, right? The collection of data, moving right along. We talked about probability versus non-probability samples, and there are non-probability methods. For example, there are cutoff methods or model-based samples. So that might be sort of like where I run up and I get the first 30 penguins I can find, and then so that would be like a cutoff. I just cut it off when I get 30. Usually there has to be a good reason to use those, or they must be able to measure estimation error in some way, because like I said, you usually at the end of the day, you want to give a confidence interval or a margin of error, and you have to be able to measure estimation error. Let's skip. Non-response bias can really be analyzed. Your goal really is to get the highest response rates and unbiased responses, right? A lot of times non-response analysis is done to try to figure out is there a pattern among people that we didn't get. We tried to sample these other 500,000 penguins, but they all run in the water. So what's the pattern there? And how could it bias our findings? And another thing people do, and it's considered a very good practice, is you can oversample hard to count populations. So, I would say that in our penguin analogy, we're sending scuba divers into the water after the harder to count penguins. And let's delve a little bit deeper into that. What is that? Because this is something I really did not learn about until I think I worked for City of New York. It's just not something I thought about very much in my scientific endeavors, but it really makes a big difference in the surveys that you read, and knowing about undercounts and consequences is a great thing to know, just to interpret the findings that you read, even if you're not a surveyor. So any questions up to this point before I launch into that? I'm talking and not letting you guys talk. Okay. Well, undercounts happen all across the world. And they're usually in 4 categories. So the hard to count population is a term that the UN uses, and it is a priority for the UN and also and the US government to prioritize hard to count populations and make extra efforts to get surveys to them. So that's our general scientific practice. So usually undercounts happen when people are hard to locate. That is when, it could be a nomadic people. It could be people who are hard to identify due to some kind of stigma or motivated misreporting. So if I ask you, are you a thief? You might say no, and then it's just hard for me to identify the thieves because it's hard to locate. That can also just be hard to identify as well because a question doesn't really ask it well. Hard to contact could be people, there's populations experiencing homelessness are generally a little harder to contact, especially in those days when they sent out mailers. Even now, if you don't have a certain type of cell phone or a certain plan or broadband access, you might be hard to contact depending on what methods you're using. What about people in gated communities? They're hard to contact if you want to go knock on their door. There are people that live like way out in the middle of nowhere, you know, with fences around their yard and lots of dogs, and they do not want you in their on their property. They're hard to contact. And once someone's contacted, they could be hard to persuade. So they may be reluctant to participate for whatever reason. They might feel they're too busy. They might just be simply busy. Or they might be, you know, they feel like this is government overreach. That's a big reason why people sometimes just don't want to participate, or they don't want to answer every single question. That's an increasingly given reason. Or they could be hard to interview. Like maybe you found them, they want to participate, but they just you know, have a lack of a shared language perhaps, or low literacy, or perhaps some form of disability. So in the I gave you in the links on the slides, and I think, are we sharing these slides out to, I can well, yeah, we can share the slides later when we give a link to this tomorrow. But the census tools I've given you are just some maps that you can click on if you want to see metrics for defining if something is hard to count, whether or not your area is hard to count, and then the effect of that on response rates, because as you can imagine, harder to count, lower response rates. In the US, usually the hard to count people include population 4 and under. For some reason, people just don't report their small children as often. The population 18 to 24, oh, you college students, and also non-college students, just this is a very mobile group. And often they're renters, and renter-occupied housing units are hard to count by themselves. Populations below the poverty level are harder to count. People with difficulty speaking English are harder to count. And you'd be surprised, I mean, LGBTQIA people are harder to count. You know, there are a lot of different situations where, and you know, they may be all usually related to, like, if you're in some kind of stable housing situation, you're usually easier to count. But I would think of the hard to count people as the fast penguins. You know, they're just they want to go on their way. They don't want you to get their antibodies. You got to work a little harder for them. Then what about when you get to them and you ask these questions? Here's a question that you may have been asked on a survey before. It's about race and Hispanic origin. And this is not my favorite question to ask people or to process, but it's done for a number of reasons. The left side box is the question that actually appeared on the 2020 census last year. It's the one that's been on, it's basically kind of the one that's been on there for a while. The one on the right is the one that a lot of statisticians proposed that it be changed to. And I was one of them that wanted the one on the right to go on the 2020 census form for a number of reasons. But you can see that basically the clock ran out. We had to submit, you can do, you know, all of your wonderful justifications, and then you can submit your process. But really the Office of Management and Budget is the office that chooses what the governance structure is for federal questions. So they can say, we're going to go with the new question or the old question, and they didn't decide on the new question before in time to put it on the 2020 census. But I like the new one better than the old one, because the old one, well, for me, I'm from California, and I think a lot of people here think of Hispanic, Latino, or Spanish origin as kind of a top level racial category. They don't think of it as an ethnicity outside of a race. But so if you're Hispanic on the left side, you get asked twice, really, you know, what are you? And you may not know what to do with the second question. And usually a lot of times people choose some other race and print race Hispanic on the second part. If you are Asian, you have a whole bunch of check boxes, right? If you're a Pacific Islander, you have Guamanian, Samoan. I mean, why are there check boxes for Asians and Pacific Islanders and not for the other groups? papers and papers are written on this. There's a lot of historical reasons why it ended up this way. But in cognitive testing, I guess just one thing I want to share with you guys about my experience in all of the American Community Survey and census tests is you can cognitively test a question in a lab all you want, and it's not going to be as valuable as a field test. So a field test means you actually send it out and you have like real interviewers who are really getting paid $12 an hour tops, going to people's houses and in their gated communities and really trying to find out if they're of Hispanic origin, and not people that have signed up for your cognitive test and are there volunteering their time for an hour and maybe getting paid a little bit or something. One of the surprises that we had was there was going to be a category called Middle Eastern and Northern African, MENA. Would be a separate category, because right now people, what if you're like say Egyptian, what if you're from Iran, right, or Tunisia? And there's so many. What if you're from Brazil? There's so many places that people just do not know what to do with this question and just want to sit down and just have a conversation with the writers, like, what are you thinking? But for that reason, a lot of times people just don't answer these questions as well. Yeah, Kayla, I'm saying as a researcher, I've learned to have less predetermined notions of my participants. Yeah. So when we tested the MENA question, the people that we tested, it worked well. It worked very well in cognitive testing. But then when we sent it out to the field, I guess maybe we hadn't, it wasn't me personally, but it was my colleagues. Maybe we hadn't selected the proper survey frame, or I'm not sure, but what we came back with was that about, by far the largest group of people with the largest ethnicity that identified as MENA were also identifying as Jewish. And so we just didn't know what to do with that, because that didn't happen in the cognitive test. It did happen when we sent it out to the American public, and the rubber hit the road, and that's the data we got back. So then there was a big debate about, well, do we want to categorize people who identify as Jewish as non-white or not? So it just, again, didn't make it, the change didn't make it onto the form because of what happened in the field testing, even though it looked pretty good before we sent it out. So that's just an interesting fact about the MENA question for you. Really, I think in the real world, what you young folks, what you students especially are going to be dealing with is user experience design. Doing a lot of research on how a computer-based or internet-based survey performs. So you have a lot of tools to do that, though. You have paradata. You can understand behavior such as multitasking. You can see when people are exactly when they cut off their survey, exactly how long it took them before they decided to throw it in the trash. And these are things that you didn't have in the past. So I just encourage, I'm not going to go through the whole body of research, but I would just encourage anyone interested to look up survey methodology and modality studies. Modes, what mode means is usually, did you use the phone? Did you use the internet? Did you use a piece of paper? Did you take someone's blood, or did you maybe just collect their data without them knowing, just as part of an official function or an operational function? I know that there are studies of having effect of the choice of mode of communication now, because now with mobile tablets and phones, you can choose and go back and forth between voice, text, and video. And it's been shown that there's not that much influence on data quality. You can use any of these and the data quality will be good, but your problem will be, are you getting to the right people? So do the people you're trying to sample have cell phones, etc. Also, what about push designs versus like a regular question response design? There's all kinds of studies about marketing and how to really get the best response rates. When you're processing and editing your data, so this is after it's collected, it comes back in. Coding is probably I know there's a lot of talk about where bias comes in, or researchers' bias comes in analysis and inference, but I think in code, it starts with the concept. Bias can start all through the chain. But in coding, it can really, really creep in, because this is where you're turning reality into something digital, right? I mean, even, the collection of data, you probably turned whatever the reality was into some lower resolution thing. Maybe, someone wrote in their race as, I'm from Venus, right? And I've seen that. And then you code it as other. So what is it? It's just other, right? In the final analysis, you lost that person's comment, right? In editing, actually, I can talk for a minute about the biggest coding exercise I ever did. Was I was in charge of the the surveillance of spoken languages in the US. And the coding system that we had to measure spoken languages we had about 380 codes, and it was very unevenly distributed. There were tons and tons of codes for European languages. There are tons and tons of codes. Actually, we had pretty much every Native American language coded, but very, very few codes for languages from Africa, very, very few codes for languages from parts of Asia. And so the task was to make it more equitable and better measurement, and more granular. So for example, if you were a Somali speaker, if you spoke language Somali, you would have been rolled up into the category of Kushite, which is some old linguistic term that no one uses anymore. But in tabulations, we wouldn't even be able to find how many Somali speakers there were, because they would have been rolled up into, category 300 Kushite, right? So I took it from 380 categories to 1,300 categories that were like all the languages ever observed in the US ever. I used to go through all of the write-in responses. So you can imagine how many interesting languages. People speak Dothraki, they speak Klingon, they speak Elvish, those are pretty much all coded as other. But again, so coding, when you're doing coding, it really is just taking something and putting your filter on it. Putting a filter on it that is through your lens, and usually through your culture. And sometimes it's operational, like you didn't choose this categorization scheme at all. It just, you inherited it. So that was nice for me to be able to have the autonomy to change my coding structure of the field that I was working on. And now we know how many Somali speakers there are to the block. Not to the block level, but to the county level, I think. Imputation, so editing is when you, let's say I put in that my birth date was 1952 and that my age was 100, right? It's those things don't add up. So when two answers are logically inconsistent, it's okay to do editing, but you have to think about which one is going to be right. Did this person lie about this or that? Or and with computerized tools, actually, there's less need for editing, because you can have a pop-up that says, "Hey, you put in that you're 100, but your birth date says 1952. Which one's right?" Where you couldn't do that in the past with paper forms. So editing is less necessary, but imputation is something that people usually don't think about. So sometimes I ask students, have you ever worked with imputation? And they say no. And I say, have you ever worked with synthetic data? And they say, oh yeah, I'm doing a project with synthetic data right now. Synthetic data is imputation. What it is it's filling in missing data. So you could have missing data that's missing at random. Maybe a virus got in and ate your file or something. I have never seen that happen personally. So theoretically, if your data is missing at random, you could just go find like the average value for that field, and you could replace all the missing values with that if it's missing at random, but usually it's not, right? Usually there's a correlation between whether, that penguin ran into the water and whether the penguin has the antibody. But there can be other tools you can use. So I think one best practice is using the tools from the other parts of information that you have to make a logical imputation. So for language spoken at home, think about what you would use to impute that. What we did use was place of birth, citizenship, age, language spoken by other people in the house, whether someone lived with other people in the house. And so this is a specification that's like 100 pages long of, how to edit language spoken at home. Another question I was in charge of, this was a tougher one, was do you have broadband internet access in your house, right? How in the world do you figure that out? There's no one else in the household to look at because you're looking at the household itself, right? So what we would use is the nearest neighbors usually. Like, if your neighbor has this, they're going to just give you the value that your neighbor has. One more thing. I just want to talk about weighting. So when you sample, you really, this is what you might want to hire a survey methodologist to do your sampling and weighting. This is the hardest part. This is what you have to really go to school for, to learn the equations for. But the reason why you do it is because usually what you get as far as your respondents is not the same as what you expected. If you break it down into different demographic categories. So here's this box gives you an example of a poll that gives the US population and the different totals that fall into the different gender, age, education categories. And then the unweighted total is how many of the respondents that responded to the poll, what percent were, usually they only give the choices male and female, you gotta choose between those, and then your ages. And then, obviously under 18 wasn't asked this poll, probably because it's a voting poll. So what you would do in this case is you would, if you got 29% age 65 plus, they're overrepresented in the sample versus the population. So you would actually weight their answers a little bit less. And the people that are underrepresented, like the ages 18 to 24, you would weight their answers a little bit more. The consequence of this is that the people in the underrepresented groups have to represent more people. So, maybe you only have 2 18 to 24-year-olds there, and their answers are going to determine what your conclusions are for all the 18 to 24-year-olds. So there's much more potential for bias by doing this, right? So always research better methods. And then you got to think about explainability as well. Oops. For the data scientists here, a lot of you enjoy machine learning. A lot of you are Bayesian theorists, and maybe you're too cool for school when it comes to NHST, which is null hypothesis statistics, or null hypothesis significance testing, t-tests and regressions and ANOVAs and stuff like that. I really love those more, I think, modern methods of explaining stuff. But when you're explaining things to a non-technical audience, like policymakers are increasingly technical, but it's often much, much easier to explain a multiple regression as opposed to what happened in your machine learning model that predicted this thing perfectly, but you can't say why. We have time, we can talk more about that. But as far as dissemination of information, you do want to report on whatever you agreed upon, or else you probably won't be hired again as a survey methodologist. So let's say, in the beginning, you did your planning really perfectly. And so you've timed your survey the right, to be run at the right time. You got the right people, you got the right precision required of the estimates. And let's say you delivered all your answers to the Penguin researchers, specific questions, right? You wrote up your reports. What about the unaggregated data you collected? Do you just sit on it? You can. It depends on your job. One of my jobs has been to produce open data portals where the government gives the public access to data just because it's not, the government agency doesn't own the data, the public does. The taxpayers paid for the collection of it or whatever. So part of the public services provided is to put it out there. But if there's privacy issues, you can't make a public use file. So I've probably made many more public use files than most people have, but they're really less useful. There's a huge trade-off between privacy and analytic agility. So the public use files that you typically will see are very aggregated up. So they maybe report on something by county or by sub-region or by city or something like that, and they won't give you the individual records for the people for each person. And sometimes you need those individual records to do certain kinds of analyses. So sometimes you can have varying levels of access. You could have those public files. You could have a restricted file where it's, someone has to submit a research application to get into this part and you keep track of it. Could be very restricted, like they have to go through, there's some processes I know of that go for years before someone gets access to the restricted data. And then there's sometimes just spread ASAP. It's not a typo for shared. That means like after you collected the data and you put it in and code it, you destroy it. And only the coded data is ever recorded. And I want to give a plug for IPUMS. If you've never used IPUMS, it's a pretty good resource for all kinds of different federal stats. They're put out in areas called PUMAs, public use microdata areas, which are equivalent of counties pretty much, except they are controlled for, they're controlling for population levels. So each PUMA has about the same population as opposed to counties, which could have millions of people or 30 people, I think, is population of 11 county Texas. So the PUMs are really useful, and IPUMS collates and curates a lot of different years of public use microdata and gives you a lot of crosswalking information and resources to use for that as well. So you can plan to put a version of public use data out, and one thing you can also put is confidential microdata and have people submit applications to see it. All right, so we have a question. I have a couple questions. One, can you estimate from Andrew, can you estimate the weighting if actual proportions are not known? Okay, sorry, yeah. Not well. So the weighting actually depends on the column here where we, the middle column, US pop. Is this the truth? Is it the exact truth? It's probably the results of the census, which could be a little bit off, right? I certainly can't. So the accuracy of anything to do with a survey that uses weighted data depends entirely on the accuracy of the population parameters you are weighting to. For me, that's one reason I went from moving survey statistician back and forth to the population estimates team and then back to the survey. So I was working with both the denominators that we're controlling to, and then the numerators that were the actual characteristics we were finding. But so there's a serious program that estimates population in between censuses, where they add births, subtract deaths, and add international migration in as best they can, and then come up with an annual population estimate. Those are the best estimates that the federal government puts out. Here in San Diego, if you're in San Diego, we have a group called SANDAG who does their own population estimates, and they can use local knowledge and add those in. They take the census estimates, the most recent ones, and then add in a little bit of local knowledge about property development. And then they create an even more exact population estimate for parts of San Diego. So that's what I would advise people to use as the very most accurate population estimates. Either those federal numbers or SANDAG's numbers. Does it help? But yeah, there's part of why I put always research better methods is because that team is always researching better methods too. They're always trying to evaluate whether the count was right. But the hardest thing to measure is international migration. Oh, it's hard, especially because we don't ask people when they leave a country. There's no survey that asks people if they leave the US. The Mexican census actually does a much better job with it. They have a different set of questions. And actually I do a bang up job in estimating international migration. So we use their stats over here quite a bit. Any other questions? Comments?
I had a question actually. I
Sure.
was trying to type it in the chat. How exactly do you when you get qualitative data, like when someone writes in a bunch of ethnicities in the text box, for example, how do you go about like transferring that into quantitative data?
It truly practically, it depends on how many answers you get. So if if it's a census and you're 300 and whatever million people are coming back, you're going to use more automated processes than if you surveyed your soccer team. And then you can kind of go through and look more closely. So you really have to, that's where coding comes in. And that's why I say bias can come in really huge at this step. Because as you're taking someone's, whatever they wrote in that blank, and turning it into whatever you think is or whatever you and the question askers have agreed upon as how you're going to report out this finding. You're really turning the world into like a really, low resolution digitized version of itself. So if you can, you can use quotes and qualitative data verbatim in your research if that's allowed for you. If it's a small sample, or if you're trying to describe a really, deep, long interview with somebody, you can use quotes. You don't have to code everything, in order to convey something. But if you have a lot of a lot of people, yeah, you have to code. So actually, the race coding system is really complex, because you can answer more than one. So there's, you might be code 1, 2, 3, 4, 5, 6 if you checked every single box, and you might be code just 1, 2 if you checked I'm white and black, or you might be just other. But usually, if someone, I know you can use automated systems where a human will code some of the things. Like someone says, I speak German, and then I write German as code 3, and then the next person that writes in the word German, it'll go to code 3. Or if maybe it's a misspelling of German, it goes to code 3. You can use some machine learning to try to help you with coding of huge amounts of stuff. But usually, it takes somebody to set a precedent for for that algorithm by coding a whole bunch of things. So I recommend interns. But yeah, I actually had to code all of the responses for recode all of the responses since 1980 to, I guess it was 2016, that had ever been written on a government survey about what language you spoke. So I saw the whole range of what people could possibly answer. So having someone who's seen that whole range is good too. If you, then that's better if you're going to make the coding system. I also just think granularity in coding is really good. So more codes, more better. You can always roll it up into an aggregate. So codes 1 through 10 are Romance languages or whatever. And you can always go back in and recode it. I also think saving, if you can, save the actual qualitative answers, because you may have to go back in. In that example of the languages, I had to go back in and recode the ones from since 1980, but they had been saved. So we were able to do that. Okay, another question. When looking for online data sets, what are some things you look for in a good data set, and what are red flags to avoid? Oh, there's so many red flags. It's online data sets. Usually I like a lot of information. I want to do something complicated, so I look for something big. I'm like, okay, does this have a whole lot of records for my personal taste? Or a whole lot of variables, but really a whole lot of records is great. And if something is aggregated, I'll give you an example of a good one that we have on data.sandiegocounty.gov is our medical examiner data. If you look at that and Google medical examiner data, San Diego County, or just look at the website, I think that's a good one because they've aggregated years and years and years of data. So you don't have to go through and look at this year and then this year and then this year and download it all and put it together, knowing that people are going to want to do a timeline putting different years together and crosswalking them makes for a good data set, I think. Also, just documentation. So you have to be honest about your limitations. So if you have some good documentation around it, technical documentation that says, well, this is how we took this sample. This is, we did, everything was, we took a sample of everyone that had an address in the US, but we missed the people experiencing homelessness, right? We missed the people that live in vans, or whatever. You know, and just explain those relationships between your sample frame and the population and the response rates, all those limitations. So for me, good technical documentation is wonderful. I've written a lot of it. I've read a lot of it. Not many people read it, but when you need it, oh, it's good to have. Yeah. Red flags to avoid. Gosh, I guess anything that just is not, I like metadata. I like when things are labeled out. So if there's not a lot of description on each variable, I really don't like that. Like what am I looking at? Unemployment rate, where did you take that from? What do you mean by city? Is it the city definition or what? So yeah, I really like when everything is labeled very well. So red flags, if it's not labeled well, it means it was probably uploaded hastily and may not have even been reviewed or whatever. So yeah, probably the more it looks, you can tell when someone is taking care in making a data product, right? So an online data set is a data product. So taking care means thinking about your user, but a lot of online data sets are really hamstrung, or is that a word? By the privacy limitations. So one rule that we would use at Census was if a cell of a table contained data that was taken from less than 3 households, it would be suppressed. That's called the rule of 3, the great rule of 3. So that's one rule you can use, is just like have a minimum level of detail that you're willing to go down to, and actually suppress data that doesn't meet that and give out the rest. So that would be another example of people taking care and getting the data out. What else? I think of some good non-governmental. I think Uber has a cool open data portal. They have mapped every single commute time. Let's say in Los Angeles, right? If you want to know how to get from point A to point B, Uber knows. You know, someone has driven from there to there, and they have basically a really good data set of commute times all around different cities. And it used to be that we would ask people, where do you live? Where do you work? How long does it take for you to get there? And use those stats and crunch, thousands and thousands of estimates that way. So I really, I think it's becoming more, I think Amazon has one coming out. It's becoming more popular for companies to provide some kind of open data or research about their data that wasn't part of their operational mission. It was just, for the public to be interested in. And I think those are good. So I like those. I like anything done in the public service. I like when the person or thing being measured is taken into account and considered as much as the researcher, because that's not usually done. It's usually the person taking the data takes what they need and then they run away. Or, they get their professional accolades or whatever they need from it. But responsible data to me is when you are taking into account the people you're measuring, or even, the environment you're measuring, are the penguins. And you're thinking about how each step of your work is impacting them, and ultimately how it's going to impact them. Is it going to land on them in a way that they actually like, and don't assume that you know what that is, right? So that's, to me, what good and responsible is, just in general. Anyway, I hope you all enjoyed my talk today. I think you can dig into some of the references in here, and I think you might have a little bit of fun with IPOMS and the census hard to count maps. You can see what's going. They're claiming a 99% response rate for almost every state except for Louisiana. Louisiana's looking bad. Yeah, I'm sorry. And so therefore the data from there will not be as good. So we'll see. I don't know what happened in Louisiana. Kayla, any final thoughts or questions, or shall we thank everyone?
I mean, yeah, thank you everybody for coming today. I learned so much. This is definitely the brush up on statistics that I needed. And I think it's super valuable information too for anybody, whether you're, studying machine learning or anything like that. So thank you so much, Christine.
Yeah, thank you all for showing up. And thanks for the great questions. And please feel free. I have my email is Christine@datasciencealliance.org. Please feel free to contact me with any other questions you might have, or just thoughts.